All right, welcome to lesson 32. This is probability. Page 210 in your book, so you can follow along. And what probability is the likelihood something is going to event. Some event is going to occur. I can't talk today. Excuse me. So it's the likelihood that something's going to occur. To represent the probability of an event, we can use some notation for that. So we'll call it event A. So the probability of event A is we have the impossible range all the way to 1, which is certain it's going to happen. Okay, and we could do 1/2 where you got that 50-50 shot. So anything over here is unlikely to happen, and anything north of 1/2 is likely to happen. So what that means is the probability of an event is recorded as the number of favorable outcomes over the number of possible outcomes. So the number of favorable to the number of possible outcomes is the probability of an event. So, therefore, got a circle here divided up into 4 sections, A, B, C, D, with a spinner going on in here. There it goes. Here's my spinner. It stops at A. What's the probability that the spinner, oh, my phone, that was a long phone call. So what's the probability of my spinner stopping on section A, sector A? Well, the probability of that happening is 1/4, because I only have one favorable outcome out of 4. What's the probability of stopping on A or B? Well, then it goes up a little bit. That is 2 1/4. 1/4 plus 1/4 equals 2/4, which equals 1/2. So that's a much greater probability. If it's in any sector, if I want to know if it's A, B, C, or D, well then I know it's going to happen. So it's a 1. My probability is a 1 because you know that's going to happen. That's a 4 in 4 chance. 4 possibilities, 4 favorable outcomes out of 4 possibilities. That's boom. That's pretty cool. Probability is expressed as a fraction, decimal, or percent. We often use the word chance when expressing probability in percent form. So usually when we talk about chance, we refer to a percentage point. Now, if I go back to the spinner before that I had, example 1, what are odds is the ratio of what is the chance that it's going to happen in sector 1. Well, 1/4 is also 25%, right? Now, what are the odds that it's going to stop? Now, when we talk about odds, we talk about something a little bit differently. When we talk about odds, we're talking about the ratio of number of favorable to unfavorable. So we're doing something totally different. Number of favorable to unfavorable. So we talk about odds, and we refer to odds in a colon. So if I want to know about that sector A again, and remember it was a 1 in 4 probability or 25% chance, the odds are 1 in 3 because it's 1 favorable to 3 unfavorable outcomes. So as you can see, my unfavorable is much, much more. So now let's go on to something else. Something called sample space. When we have an experiment of probability or outcomes, sample space is how we record it. So if I toss a coin twice, if I take a coin, let's see if I can do this. If I take a coin and I don't have one, I was thinking I had a coin. If I take a coin, here's a head, and here's a tail, head and tail, and a coin, what is all the possible outcomes. I would indicate that by my sample space. So all I would do is make a chart. Just do my sample space. So I got my first toss, and I have my second toss. My first toss and my second toss. And my first toss, heads or tails. And my second toss, heads or tails. Okay, so 2 tosses. My probability, my odds are HH, HT, TH, and TT. Okay, that's it. Pretty simple. So we could do lots of different things. So if I go back to that spinner that I had in example 1. Okay, here's my spinner in example 1. And my spinner is spun twice. Is the probability of spinning A more likely with 1 spin or with 2 spins? So the probability of spinning A, is that more likely with 1 spin or 2 spins? Okay, so let's graph that out. So I want to find the probability of getting A once and the probability of getting A, of not getting A at least once. So let's make a chart. First spin, take that spinner on a spin, second spin. Okay, first spin and second spin. So let's list this out. We have A, B, C, D, and going down the other way, we have A, B, C, D. Here's my chart. And then I divide it up into 4 parts. Okay? And then I write them all in. So AA, BA, CA, DA, AB, BB, CB, DB, AC, AD, BC, BD, CC, CD, DC, and DB. All right, so by looking at all of it, at least once to get A, at least once, how many times does that happen? Well, it happens to get A at least once. It happens a few times. It happens, notice how many I have, I got 16. So it happens 4 times over here. So 1, 2, 3, 4. It also happens this way, 1, 2, 3. That's a total of 7 out of 16, right? That's my probability. The probability of getting it no times, the probability of getting it exactly no times then is a little bit differently. Okay, not A, count out the ones that are not A. 1, 2, 3, 1, 2, 3, that's 9. So 9 out of 16 is no A. Then my very first thing I asked you is what's the chances on the first spin or second spin of it? Well, is it going to be the first spin or the second spin? Because that's what my very first question. It would be more likely that we get A with 2 spins than with 1 spin, right? And that is true. That we will get A with 2 spins versus 1 spin. Okay, now we can expand on that to do some other stuff. If somebody flips a coin 3 times, coin, 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 head, 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 do, 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 do. Okay, coin 3 times. Which is more likely? They would get heads at least once, or that he will not get heads at least once. Probability of getting heads once and the probability of not getting heads once. So this one's going to be a little bit differently because this has got lots of stuff going on. So my first toss of the coin. So my first toss goes like this. I get heads or I get tails. Then my second toss, okay, my heads is that we get heads and tails. And my second toss over here, I could get heads or I could get tails. My third toss, though, I could get heads or tails, and I could get heads heads or tails. And then over here, again, I could get heads or tails, then heads or tails. So lots of stuff. Oh, I messed that up, so let's rewrite that down there. So lots of possibilities. So my outcomes are going to be, they're going to come out to be a little bit differently. I could get 3 H's, H, 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 I get H, H, T. I could get H, T, H if I'm H, T, H if I'm following my patterns. I could get H, T, T. I could get T, H, H, T, H, T, 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 H, or T, T, T. So I can get lots and lots of different outcomes doing this. And all I had to do was follow the lines H, 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 T, H, H, T, T, and so on. So all I gotta do is follow all the lines to the ending, and I got it. All right, so there's 2 other kinds of probability. There's theoretical probability. That's the mathematical side of things. That's what it should be number-wise. If you do your analytical stuff, that's what you should end up with. But then there's also something called experimental probability, which is determined by how it actually turns out. Because lots of factors affect even something like a coin toss. Okay, whether it's the way it's tossed, the wind, all kinds of things could affect the coin toss. So there's 2 different things. That's determined statistically, or actually doing the thing. So there's a whole different thing. So if a basketball player makes 80 free throws in 100 attempts, then experimental probability is 4/5, because 80 over 100 reduces down to 4/5. Okay, that's an 80% free throw shooter, because that's experimental probability. Batting average in baseball is also experimental probability. So let's take this down to one more problem. I'm going to do this pretty quickly. If Emily is a softball player who has 21 hits and 60 at-bats, 21 hits, 60 at-bats, express the probability that Emily will get a hit in her next at-bat as a decimal number with 3 decimal places. So I need to divide 21 by 60 to get 0.35. Emily's coach needs to decide whether to have Emily bat or to use a substitute hitter whose batting average is 300. Batting averages are usually expressed without a 0 in the ones place. How would you advise the coach? Which one's better, 350 or 300? Answer is 350. Emily should be at bat. Thank you. Do your practice problems.